intersection of three planes. So let's give you some intuition on what happens when you take three planes and you try to find out how they can possibly intersect, or maybe not. Now, my assumption is that you're familiar with the intersection of two planes. So, you know, what happens in 3 dimensions. There's really just 3 things that can happen with 2 planes. I'll put up a link up above there for you, so in case you have forgotten it. So now in here, what I have is I have given the standard equation or the scalar equation of 3 planes. Now I haven't given you any values for A, B, C, and notice we have plane 1, plane 2, and plane 3. Now, with those 3 planes, of course, if it's just algebraically given to you like this, you're not going to get much intuition. But if you can draw yourself some pictures and visuals, you certainly can try to figure out, okay, so how do these planes intersect, or possibly not? And then you can figure out some properties of those intersections, just so that you get some intuition behind this. So let's take a look at what can happen. So if I have 2 planes, so if I kind of go back, I'm going to just sketch this out for you. So let's imagine this is one plane, and then let's imagine that this is another plane. So we have, okay, this, and as you can see there, so basically, you know, there would be a line, okay, intersection in between those 2 planes. That's going to be my first approach of just 2 planes. So now if I extend this and now bring it into a 3rd plane, so now what can happen if I take a 3rd plane, and how can I slice this up? So I'm going to duplicate this to make it easier for myself. So what else can happen if I now introduce a 3rd plane in here? Well, one of the things that can certainly happen, you can have another plane which basically will intersect both of these planes. So, you know, if I'm going to draw this out, this is going to be a little bit difficult for me to draw, but I'll give it a try. Okay, so I'm going to draw it, okay, like this. Okay, this now extends back in the back over there. Okay, continues on. This is my 3rd plane, then intersects this one. All right, and it goes over here. So let's, okay, do something like this. Boom, and then it continues on over there. All right, so let's do that. So visually, okay, as you're kind of looking at this, so now this would intersect on kind of the horizontal, at least the way that I drew it. Okay, so it's going to intersect this one, okay, this plane, okay, something over here, and it's, of course, it's going to continue on. Okay, so that's the one intersection. So it would have been a line intersection between this plane, okay, and the one that cuts through it. So it would cut it like this right there. Okay, so it would have been a line, but it also will intersect the other plane, which is going to be this plane right there. And then now notice the red one goes like this, so it intersects it, okay, in this way over here. So that means it also, you know, intersects this plane over here, okay, like so. So that's what we have. So now if I would take this, so we have, you know, my line. So here's my vertical line, okay, so that's the intersection coming in. So this is from right there that you see. And then I have, you know, oddly enough, I mean, I used red, but I would also have a line, okay, which intersects right here. And that's, you know, this particular intersection right there. Now, of course, these are infinite lines, right? And then I have another line, so this is going to be this one. So I have this intersection kind of going, you know, like this. Let me just draw like that. All right, so that would have been it. And so what you would find is that, you know, these 3 planes would have been intersecting here at this one particular point. So that's one thing that can certainly happen, right? And you can visualize that. Now, of course, the way that I drew it, it's almost like I'm drawing them that they're kind of 90 degrees to each other, which we call orthogonal. So if you hear that word orthogonal, I think I heard it in university for the first time. Or maybe not, maybe I forget. So orthogonal just means that things are at 90 degrees to each other. So this would be intersecting at one point, right? So you have three planes and they're intersecting now at one particular point. So I think that's, relatively easy enough to be able to kind of comprehend. Now, what else can happen? Because, I want to give you intuition in what happens and make this, as visual as I can. So if I take two planes, now, of course, I can have another plane. And, so strangely enough, you can have another plane. And maybe in this plane, also, is maybe parallel to one of them. And it intersects, this one. So it goes on like this, kind of like the other one. And it intersects over here. So in this particular case, so you would have two lines, right? So you would have this line, because you would have an intersection between these two particular planes. And then you would have another one, intersecting over here. So technically, although you have an intersection, you have two intersections there, and there's two lines that are going to be, I guess, kind of parallel to each other. And that's because the two planes are parallel to each other now. So in this case, there's actually no formal intersection at all, right? So there is no intersection. Now it creates two lines for us, right? So there's two lines, of intersection over here, but we want to know what is the intersection between all three. Well, they don't intersect. So there's actually no intersection here between all three lines. There are intersections between all three planes. There are intersections between two planes, right? So as you can see there, between one and another, and then one and the other one as well. But technically, these planes actually never intersect. So this plane right here, and then this plane right here. So the three planes do not intersect. All right. So that's another possibility that we would have. Now, do remember that in this case, that I have just now given to you, what you will find is that because these two are going to be parallel, so you're going to find that the normal, the two normals, I guess, of the two planes, so these normals are going to be parallel to each other, right? So those two normals are going to be parallel, and then one of the normals will not be, right? So that's something that you will have. And by the way, when we do have, so this is just some terminology, when we do have an intersection, right? So if we have an intersection between all three planes, so in this case it was a point right there, we call that that it's a consistent, system of equations within here. So the word consistent means that you do have an intersection. Now in this case we've only seen a point, right? So that there is a solution to the three planes. They do actually intersect. Now, when you do have something like this, when there is actually no intersection at all, and that's because the two are parallel to each other and they're not actually on top of each other, then that is inconsistent. So we use the terminology inconsistent because there is no solution at all. So that's another thing that can happen. So now, let's keep on chugging here. So if I duplicate this, what else can happen over here? So if I take that, I can certainly have another plane. And as I just mentioned, what might happen is that this plane is actually on top of the other plane. So it's going to be a little bit tough to draw here, but let me just give it a shot. So let's assume that these two planes are on top of each other, right? And if this happens, if they're on top of each other, now you do actually have a solution. So within here, so you will have a solution, and that solution is going to be that actual line, right? So this is going to be now the line of intersection. So you will have two normals, that are parallel to each other, but not only are they parallel to each other, that you have there, they actually are going to be the same plane, right? So now we have seen that actually with two planes, they can intersect, and they can be lying on top of each other. So this is going to have a solution. So this does have a solution. So this would be, you know, we would call this a consistent, okay, system of planes in here, or equations. So this would be consistent. It is a solution, and the solution is actually a line. So in here we saw that it was a point, and in here now we are actually seeing that it can be right there. It can be a line, and now that is only going to be true, okay, if you have those two planes right on top of each other, or okay, they intersected a nice particular way, which is going to be the next example that I'll show you actually, okay, within here. So again, to get intuition into this, so you know what else can possibly happen. You might think that, oh boy, well, we have three planes, right? So there's quite a lot of things that can happen. This one's going to be a little bit challenging to try to draw, but I'll give it a shot. So let's imagine that this plane kind of goes like this, right? So it goes like this, okay? So it cuts through, right? So you have one plane, you have another plane, okay, which goes in, okay, and then you have another plane. And in this case, they're also intersecting at the same, so at that line. Now, notice that the planes are different. In this case, you will find that none of the normals are actually parallel, right? So the normals are not parallel to each other. However, the normals are going to be coplanar. So what that means is, so if you think back in terms of coplanar, so that means if you took the actual normals throughout, and you will find that they actually form a plane, right? They're all in the same plane that you have in there. And in order to check if things are coplanar, so if we have, you know, normal 1, let's say this is normal 1, you can, you know, dot it with the cross product with the other normals. So this is the triple scalar product. So you can look at that and you will find that this result is going to be 0, right? To basically show us that this is coplanar. So if we calculate that and we do get coplanar, so we're going to run into this particular problem. Now, you would have had these, okay, in this example right here. So if you were looking at here, these are also going to be coplanar as well, right? Not only are they going to be coplanar, you're going to have two normals that are going to be parallel to each other, right? So that certainly can happen. So not only are two normals parallel to each other, you also will have this coplanar property, okay, within here. And now this does have a solution, right? So this would have been a consistent, okay, set of equations here or planes, and the solution would have been a line. So that's another example, okay, that you can run into, okay, that we have seen. You know, so what else can possibly happen, okay, in here? Well, you know, unfortunately or fortunately, okay, there is definitely more, okay, within here. So if I'm going to paste this back in here, so these planes, and let me draw, you know, another plane. Now, what's going to happen with this plane, okay, which is going to be the third plane in here. Let me do the best I can. I'm going to actually extend this just so that it looks a little bit better, okay, in here, and easier to be able to view. So I'm going to do something like this, okay, so this is going to continue on there. So let's do that, and let's make this one even longer in here so that you can see these. Obviously these are infinite anyways, but this, I think this will do an easier job to be able to draw it out if it's a little bit bigger. Okay, so within here, so we're going to have something like this, that the plane basically will hit. Okay, so it's going to now intersect over here. It's going to continue on, right? So it's going to continue on, and it's going to intersect over there, right? So it's going to look something like this, right? So that's the plane. So now what you have is you have one intersection, right? You have this intersection, which is going to be another line, and then you have, you know, this line coming out over here, okay, that you see there. So it's like you have three lines And now it's the same problem actually that we are having over here. So, this problem over here, yes, they intersected, they had basically lines, but the three planes never intersected at any point together, right? So these definitely intersected at a line. All three of them intersected, and here the same. But in here, they're intersecting. However, as you can see there, if you take all three of them, this is not going to have a solution. So this is no solution here at all. So this is actually inconsistent. And what is interesting in here, you will find, okay, that this is going to be coplanar, right? So you also will find that you're going to have this coplanar property in here, okay, with the normals. So that's going to be, coplanar property, okay, in here that you will have with your normals. You're not going to have any of those normals being actually parallel to each other, okay, but you're going to have the coplanar property, so you're going to have to be careful, right? So just because you do see the coplanar, it doesn't automatically give you, the answer that it's going to be a solution in terms of a line. We might have to do a little bit of work, okay, to be able to see that. So that's another possibility, okay, that we have here. So there is no intersection, right? So there's actually no intersection for all three planes. For any two of the planes, yes, like if you take two planes, they do intersect at a line, but if you throw in the third one, they won't intersect. All right, so that's something that you're going to find over here. All right, so what else can possibly happen? Now we're kind of exhausting these all the way through. Okay, so now I'm going to take, so this again, I'm going to copy it. Okay, and let's now think about, what else can possibly happen, or have I actually exhausted these? So let's see here. So I had the point, I had no intersection, so there's basically two lines. There's one line. Okay, there's three lines now. And I think I'm running out, okay, within here. Now, so that's going to be that. But now let's go back to the idea and the concept of when we have two planes, right? So when we have two planes, what else could have happened? Well, what could have happened, we definitely had two planes on top of each other. So if they were on top of each other like this, then this does, so if I bring this back in here, so what can happen in this case is you can certainly have a plane which is going to cut through this, okay, and it's going to cut through this kind of in this way, so it's going to have that, right? And within here, so you're going to see that, so if you have two planes already starting that they're on top of each other, you are going to be running into, the intersection of this. However, we've run into this, okay, from here, right, where we had two planes, although we were starting from this point where they already started at a line. And then in here, this one just fell on top of each other. So notice this one is the same thing. So this doesn't add anything new for us. This just still intersects at a line, right? So that's something that could possibly happen. Now, is there anything, extra that this adds? Yes, I guess it does add, because what could happen is that when you have two planes on top of each other, you can find out that you have actually another third plane and it lands on top of all of those. So that means these are three planes on top, okay, of each other, on top of each other. So now, when this happens, and notice that the normals are clearly all going to be parallel. So you're going to have three normals. So that means that they're just scalar multiples of each other, right? So all three of those normals are going to be parallel because it's exactly the same plane that we have in here. So that certainly can happen. And not only are the normals going to be parallel, they are on top of each other. So every point is a solution in here. So within here, if this happens, this definitely has a solution, and the solution is actually the entire plane. So that means they intersect at the entire plane. So this is a consistent set, okay, of planes, or a consistent set of equations that give us, okay, the solution. So far what we've seen is solution can be a point, solution can be a line, and now a solution can be a plane. And then the other one, so all the other ones means that there's no solution. So, you know, they might be intersecting at a line somewhere, but they're not intersecting simultaneously at a line. So that's something that can happen. And I guess with regards to this, that's pretty much it, except I guess when you have two planes, you know, we could run into this problem, although we've covered this already, right? So you might have this, which are two planes that are already parallel, and then you can cut them through. So within here, let me duplicate this. So you can run into, you know, the problem that now you can certainly cut, you know, so this is going to be kind of the same as you've seen already. Okay, so it's like this, where there are two, you know, so right there, if they're parallel to each other, you might have a plane which cuts this through in this way, right? And then they're going to be intersecting here. But this doesn't add anything new. This is the same thing as here. So there's actually no intersection where all three of them intersect. So this is actually the same thing. So that's what you have there. And now lastly, okay, the only last possibility is going to be if you do have two planes that are, let me duplicate this. Okay, if you do have two planes like this, you might run into this problem where you have a third plane and it's actually parallel. So all three planes are going to be parallel to each other. So you're going to have the three normals being parallel. However, they don't intersect at all, right? So they don't intersect at all. So this is something that you might have, okay, within here. Now, the other one, let's see, within here, so I guess, you know, one more that could happen is, of course, that, you know, this plane, you know, maybe is on top of this one, or maybe it's on top of this one. Again, you're going to have three normals that are going to be the same, so parallel to each other. However, there's not going to be a solution, right? So it doesn't matter if these were on top or not, this is not going to give you a solution. So here, there is no solution, all right? So no solution. So now, in order to be able to, you know, so this is kind of the visuals that you have, you want to be able to see, you know, if this actually relates back, and then how am I going to see it? Because now I can see it visually, all right? So all of these things, you know, that it's great, it's wonderful. You know, I can see all of these different things, get some intuition how they intersect. But now how do I start checking these things when I am given, you know, three equations, let's say in standard form, like this? And that's something that I am going to cover in another video, all right? When the video is up, I'll put up a link up above there for you so that you can now continue, okay, this process of now not only understanding intuitively how these three planes intersect, but now you will have examples and then being able to see, all right, where am I? Okay, with regards to what's happening, is there a solution, is there not a solution, and how do I find it? All right, so thanks for watching, and we'll see you in a future video. Bye, everybody.